Let's just say for a second that there are a lot of unfinished projects or tasks in your life. Well, I guess we've all been there at one point, and it's not a great feeling at all. What can sometimes help in tackling these open tasks is to group them into related issues and then work on them one after another until that whole cluster of things can be crossed off the list. One such cluster in my life has to do with compressors, pneumatics, and anything related to compressed air. Over the years, I have collected a whole lot of interesting equipment having to do with pneumatics and compressors, and I always wanted to show them in a video. At the same time, it also happens to be the case that I'm in the possession of 3 broken air compressors and not a single working unit at the moment. And that's why in this video we will repair 3 rather different air compressors and then also have a look at my collection here and learn some basics about pneumatics. So let's not waste any time then. This is a small oilless compressor by the German company Dürr. Dürr is mostly known to make compressors for medical applications, laboratories, and special industries like the food industry, rather than your ordinary workshop compressor. This compressor came into my possession because it has a number of issues that we need to take care of. This particular device was manufactured in 2014, but as far as I know, the particular compressor pump used here is still made and sold by Dürr. The pump is rated for 10 bar maximum pressure. This entire assembly only for 8 bar though. Let's have a look at the problems then. This small line, called the unloader line, is disconnected. A hose barb or quick connector that would fasten it to the input side of the check valve here is missing. It must have broken in the past and was removed. With the input side of the check valve open, you can't build pressure in the tank as the air will just leak from the opening here. The tank is also loose and needs to be fastened. What is also interesting is that there is a solenoid valve at the end of the tank. Inside the inlet of the cylinder, we find a broken plastic thread. A small silencer was installed here, and it snapped off in the past. What actually belongs here though is a proper air cleaner. Holding the loose tank in my hand, I can feel that there is a considerable amount of water in there. Unfortunately, I can't find a dedicated drain port on the tank. But these are all comparatively minor issues, while there is a much bigger problem with the compressor pump itself. In order to get rid of the water and also fix the pump, I will have to disassemble this device almost completely. In order to work on the pump and tank individually, I decided to remove the hose that interconnects the two. We will have some fun with that later in the video, but that's another story. The motor is also electrically connected to this Condor brand pressure switch that is sitting on the air tank. We open its enclosure and unscrew the wires leading to the induction motor that powers the pump. With the 2 parts separated, I proceed by cleaning them first. Doing this, I also noticed that the motor capacitor is punctured at one spot and should probably be replaced as well. Man, this compressor really didn't have an easy life so far, it appears. After cleaning the tank as well, I decided to remove the solenoid valve on its side so that I could drain the water from inside the tank. At this point, I was still hoping that it wouldn't be necessary to unscrew the pressure switch. Water is coming out alright, but it seems that I'm not really getting anywhere here. No matter how I tilt this tank, some of the water seems to remain inside, so I figured that I might have to unscrew the pressure switch after all. And after doing that, it seems to me that maybe half of the entire tank was filled with water. The water itself looks not too rusty for a 9-year-old compressor. I've seen much worse. Now, in case you have never dealt with this yourself, it is normal that water will collect in the pressure tank of air compressors, but you have to drain this water now and then. It comes from the humidity of the surrounding air and will collect in the tank. If you own a compressor yet have never done this, you should probably do that now. With this being done, it was time to have a look inside the actual compressor pump then. After removing 4 screws, the cylinder head can simply be lifted off. Under that, we find 2 valves that simply consist of an aluminium casting, some replaceable rubber seals and leaf springs. Not much here at all, and there also seem to be no problems with the valves. There are some signs of wear on the cylinder surface though, but well, we'll find out soon enough if there is enough compression. This leaves us with this piston that works, as the name implies, without an oil bath. Moving the piston freely like this, we can hear an unhealthy sound that points to the big problem that I talked about before. This is not what a silent compressor should sound like, especially if there isn't even any compression or load on the motor. And after removing a nut that holds the flywheel down, we can pull it out, and we can also remove the piston itself. As you can see, there is a bearing inside of it with an off-center hole. This is what acts as a crank here. Now, in the German language, we actually differentiate between a Kurbel, a crank, and an excenter, in English, eccentric mechanism. It is an engineering term that might be more common in German than in English though. This eccentric seems to be totally fine though. It's not where that sound comes from. It must be from inside the induction motor, and since there isn't much in there, it's probably a broken bearing. And upon unscrewing 4 screws from the back side and using a mallet to punch out the rotor, we have found our bad bearing. Let's pull it off then. So this is what the broken bearing looks like from its 2 sides. Pretty severe damage. Apparently this is what an unbalanced load in the form of a compression pump can do to a ball bearing. The bearing on the back side of the motor shaft is totally fine, by the way. In the meantime, I have ordered a replacement bearing with the exact same dimensions. But in order to push it onto the motor shaft, I have to prepare something here. I drilled a hole into a piece of wood. And now I place this nut under the bearing. The idea is that while pressing the bearing on the motor shaft, force is only applied to the inner ring of the bearing, not the outer ring, and that is done via the nut. I'm sure there are more professional methods to do this, but I can't take much time to prepare everything perfectly all the time. The work just has to be done with what I have at hand. So I'm using the mallet again and try my best not to hit the blades of that plastic fan. It's been missing a few already. Now, this looks about right, and we can now put the motor and pump back together. I actually needed another piece of wood to make it happen, but in the end it was no big problem to reassemble the pump. After having done that, I'm also inserting a preliminary air filter here to the input of the cylinder. See, when I first got this compressor, a small silencer was screwed in here and it later snapped off. Right now I'm simply screwing in a new silencer once again, because I simply couldn't find an air cleaner with a 1/8 inch thread. One could still install a hose barb here and then attach a hose and a bigger air cleaner on its end, and well, I might just do that in the future then. In the meantime, I was also able to organize a new quick connector for the unloader line. One of the hardest parts of repairing compressors is to source the right components that you usually just don't have on the shelf. There are so many different types of connectors and connection styles and thread sizes and types. It's sometimes super annoying, to be honest. At this point, I had already installed the tank and pump back on the base plate and had started to reconnect the pressure switch assembly using Teflon tape to ensure a good seal. I was already approaching the end of the repair when I found a crack in this connector here that connects the hose to the output of the compressor pump. I widened the crack on purpose so that I could show it to you on camera. This is really one of these parts that is very hard to find. It is a 1/8 inch to M16 by 1.5. In other words, a very small inch diameter to a metric thread that will connect to the hose. I just couldn't find that anywhere, so I had to do with 2 adapters that I'm connecting together here, and this is 1/8 inch to 3/8 inch and then 3/8 to M16 by 1.5. Fortunately though, that was the last piece of the puzzle. This is what is left from a 1987 model German Käser brand 50-liter compressor that I bought a few years ago. The original pump still worked back then, but was extremely noisy, and that is why I experimented with an AC compressor pump that I installed on the tank back then. That setup actually worked quite well for a while, well, until eventually it overheated while two buddies of mine were using it at the workshop while I wasn't there. For some reason, this kind of thing always happens when I'm not home, since my other old compressor also broke after 2 years when I myself wasn't at the shop for a change. After some back and forth, I decided to buy a new pump and reuse the old tank once again. Käser, I think, make fantastic compressors, and the tank is still in really good shape. The big sticker says will never rust again, because the steel is coated with a polymer from the inside that will prevent it from corrosion. Out of curiosity, I decided to buy one of these modern, silent, oilless double pumps that you see on many compressors now. I also bought a set of new air cleaners, a motor capacitor, and a safety valve. Using Teflon tape, the air cleaners are screwed into the inlets of the two pumps that will work in parallel here. On the output side, I installed a safety valve and left one side open where the line that leads to the check valve will later be connected. A set of 4 rubber dampeners will be used to fasten the pump to the tank. And in order to make that possible, I'm reusing an old piece of steel from the scrap. A number of holes are drilled, and after that, this plate is bolted to the tank before the pump is then eventually lowered onto it with the dampeners already installed. The capacitor is connected to the plate as well. In the next step, I'm already preparing the pressure switch to be fastened over here. And upon taking the compressor into the workshop and onto the wooden workbench here, I'm also draining the water out of the tank with the help of the drain port on the bottom of the tank. As you can see, there is no rust in the water, even though the tank is more than 35 years old. That's because of the internal coating of these Käser brand compressors. The brown stuff you see is old compressor oil, not rust. This is the underside of the pressure switch. It already has 2 outlets and a pressure gauge connected to it. The old unloader line cannot be reused anymore, and I ordered some replacement. And as usual, they are of lower quality than the old parts. While the old lines were thick-walled copper tubes, these are merely flimsy copper-coated aluminium. Nuts used to be made from thick brass. This is chromated steel. On one end, this little shoulder will act as a seal. And on the opposite end, you have a bell mouth that will fit right on the unloader port on the side of the check valve. As I might have explained before, the purpose of this unloader line is to evacuate the cylinders and the line connecting the cylinders to the check valve. This happens once the pressure switch cuts the motor off. When you have no unloader line, the cylinders just stay pressurized and the motor might not have enough torque to start once the pressure switch re-engages after the pressure in the tank has dropped under a certain threshold. Last but not least, this new interconnect line is inserted between the cylinder's output side and the check valve's input. Now, this particular style of line will also not require any additional gaskets, and it will form seals at both ends while using those shoulders or rings in the tube itself. Problem is, it only works once and you have to get everything right the first time. If you disassemble this again, chances are that these rings will not form good seals again, which might mean that you might have to reorder the replacement part. This yellow contraption here is an interesting case. Before I had found this on a scrap, I had never seen anything like it before. The nameplate says Chiron Werke Tuttlingen, apparently named after the centaur from Greek mythology, in English known as Chiron. Old advertisements also show the centaur as the company logo. This was the old times when companies in Germany were still named after mythological or historical figures and places, usually from antiquity. Sometimes these were Germanic or Roman names, but most times they were actually from Greek mythology. It's just my opinion here, but I think that these old names all sound much more impressive than what we have today. Chiron still exists today. Apparently they have since specialized in CNC though. But be that as it may, back in the day they made compressors. And obviously also these portable compressors that have almost no air tank to speak of. The air is actually stored inside the welded steel tubes that double as a frame or support. This particular one still has some potential, but I know it looks really rough right now. Looking at this nameplate, we can see that it was rated for up to 18 bar, which is way more than the 8 bar many of the cheap compressors today are made for. Even though it's supposed to be portable, this 1972 model is super heavy, everything is overbuilt and super rugged. But let's assess the damage and start removing some of the broken parts. The capacitor has been ripped apart, probably at the scrapyard. There is a safety valve and a drain port, but there was almost no water inside. This pressure gauge is broken and that valve is loose. The pressure switch is also damaged. Much of the physical damage was probably also done at the scrapyard, well, because this compressor had been tossed into a dumpster. This pressure gauge, as well as the valve leading to it, and also these random fittings here that were probably connected to an air cleaner, are not original. Someone modified the compressor at some point. We're basically removing almost all of those external components to clean the compressor and rethink this entire setup here. In order to get the old pressure switch off, I had to cut through one of these old steel adapter pieces. They were so stuck that they just wouldn't budge. I also unscrewed the fan guard in order to look under it, and now I was also able to spin the motor for the first time. It moves freely, and there clearly is compression. I did my best to clean the outside of this device using various methods, including the steam cleaner. I had installed a small capacitor for a preliminary motor test. We will need a bigger one though. The power cord is connected to the motor directly for the purpose of that test alone. It will instead have to be connected to a new pressure switch. The oil was rather low, so I drained the old one and replaced it with new oil. The type and the amount of oil can be found on a nameplate. It's basically just normal motor oil. And then I installed a quick connect outlet right here at the handle. And I also had to hammer out a dent in the fan guard so that it would be possible, once again, for the motor to spin freely. And reusing one of the old galvanized reduction pieces that came with the compressor, I was also able to connect this modern air cleaner to the cylinder intake. The hard part was now to connect a new pressure switch to the tank and the unloader line. Since there is just not enough space to actually rotate the switch's housing, I went for a somewhat improvised solution. Instead of screwing it in place, I'm using a quick connector. This could potentially be a little dangerous because the switch could disconnect and then it would no longer be able to cut off the motor once the maximum pressure is reached. On the other hand, the unloader line will also hold down the housing of the switch. I just wanted to let you know that this is not my preferred way to do it. I just have no other parts to connect the switch right now. In the next step, a power cord and the motor were connected to the switch as well. After that had happened, one end of the old unloader line was cut and the edges were filed off. These parts that came with the pressure switch are needed to create a compression fitting. And it's a nice surprise that the 51-year-old unloader line just has the correct diameter for that. But the motor still needed a bigger capacitor. The motor's nameplate recommends 20 microfarads. I don't want to buy even more new replacement parts, So I connected two used capacitors in parallel here. They were salvaged from two old Miele brand dishwasher motors, and their combined capacitance is about 24 microfarads. And as you can see here, I also connected a pressure gauge. And yes, as expected, the tiny volume that fits inside the tubes is filled rather quickly. These pressure switches can be adjusted with a screw, and I limited the maximum pressure to 8 bar. This part here is a solenoid valve from the scrap. And that is actually a good segue into having a look at some of the many pneumatic components that I have collected here over the years. First of all, while you will usually find these big quick connectors here in workshops, many industrial pneumatic systems use these small quick connectors instead. This is a 6mm connector by Festo. Among others, you will find lines with 4, 6, 8, 10 and 12mm outer diameter. And here is one of the many pneumatic scrapyard finds. A small cylinder. When you pull it apart, it will return by itself to its starting position because it has a built-in return spring. This part is called a single-acting cylinder, einfach wirkender Zylinder. The most primitive way to test it is to simply connect it to a pressure source, but that is of course not very practical. What you need is a valve. To be more precise, a 3x2 directional control valve, or DCV. 3 because it has 3 ports, by 2 because it has 2 states that it can be in. What we strictly need here is port 1, which is connected to the pressure source, and port 2, which is connected to the single-acting cylinder. Port 3 can be used to attach one of the little silencers that we have seen earlier in this video. The 3x2 DCV can be used to control cylinders of various shapes and sizes. It's always the same setup. The first valve we have gotten to know here is manually operated or lever operated spring return, to be more precise. But in modern industrial settings, you will more often find electrically operated valves. This is a block of currently 4 DCVs, all of them 3x2. But this time electrically operated instead of manually. They exist for 12 and 24 volts DC and AC, as well as 110 and 230 volts AC. These ones here are 24 volt DC, which is quite common. This heavy actuator here also runs on 24 volts DC, and it already has its own DCV connected to it. It also has a small button that allows manual operation, but normally it is electrically operated. Its purpose is to open and close big valves remotely or automatically. It's another scrapyard find, and I just wanted to show you that the visible motion of the actuator doesn't necessarily have to be linear. But you will also encounter cylinders that have not 1 but 2 ports. When you extend them, they will not just automatically return, since there is no spring built into them. This is an example of a double-acting cylinder, doppelt wirkender Zylinder. So what do you do when you want to control an actuator like this one? Well, connecting the 3x2 valve doesn't really get you anywhere, since you would have to switch between the ports manually to return it. What you need instead is another kind of valve called a 5x2 DCV. Again, the first number describes the number of ports and the second one the number of states. I have now simplified this scrapyard find for the sake of making the explanation a little simpler. The 8mm line down here is the pressure source leading to port 1. Ports 2 and 4 are connected through the cylinder. And ports 3 and 5 is where the air is released into the atmosphere. In order to operate the valve, a small 4mm control line needs to be pressurized as well. Between the line and the DCV, we also have a 230 volt AC electric solenoid valve. I changed the state of the DCV by switching the electric solenoid valve on and off. Now the cylinder can be operated and returned. If I had the right hoses and connectors, I could do the same thing with these big heavy cylinders here, but I have to revert to the primitive method just for showing it. And this is a part that a viewer has given me a few years ago together with a bunch of other Festo components. Thank you again for that, I know it's been a while. It demonstrates one of the advantages of pneumatic actuators. Extreme speed is possible if needed. But what about the complicated looking symbols that we find on the enclosures of these valves? Well, even for people who are used to reading electronic circuit diagrams, this might take some getting used to. But let me help to clarify this. One reason why this looks so complicated is that there are some symbols on here that show components that are not actually connected to the valve right now. These 8 symbols represent some of the many options that you have in operating and returning the valve. While the midsection, the actual DCV, is always the same, a number of attachments can be mounted to the valve. In our case, it just so happens that we have a lever-operated spring return valve. But the same basic valve could be customized completely differently, and that is why these 8 symbols are there. The symbol for the actual 3x2 valve is just this, and here is what it means. It shows the 3 ports, 1, 2, and 3, and then it shows 2 squares that represent the 2 possible states. In the right square, air is flowing from the source at port 1 to the cylinder at port 2, extending it, while port 3 is blocked. Once the valve is switched to the other state, symbolized by the left square, air is flowing from 2 to 3, meaning that the cylinder is being evacuated, returning to its starting position, while port 1 is blocked. That's really all there is to it. With the 5x2 DCV, it's just a little more complex, but the same logic applies. You have ports number 1, 2, 3, 4, and 5. Again, the 2 squares show the 2 different states, and the arrows the intended airflow during those 2 states. But this time, whenever one side of the cylinder is pressurized, the other side needs to be evacuated at the same time. In the 1 state, air flows from 1 to 2, say extending the cylinder, while air is being pushed out through the other port of the cylinder, which is connected to port 4, from where the air is pushed out of port 5, where you could also install a silencer, for example. Port 3 is blocked in this state. In the other state, here on the left-hand side, air is coming from the other end of the cylinder, which is connected to port 2, expelling the air through port 3. And that is because it is pushed from the other side, which is connected to port 4, which gets its air from the supply at port 1. All the while, port 5 is blocked. It might look complicated at first, but it actually isn't. Hi guys, just a few final words here. One, at the end of the last episode I talked about my intention to creating this email newsletter and sending it out to you guys. Now a lot of you guys have shown an interest in it. You put your name in a list or send me an email, and you will hear from me again in this regard. It's just going to take a few weeks, maybe even months, until it's all set up, and then it's going to be a regular thing. Just so you know, it's going to happen. Will just take a while. The other thing I wanted to talk about is that I auctioneered off some of the items that I showed in my last episode. I did that over 8 days, starting with the airing of the episode, and all of the items have been sold and shipped out, and I'm very happy with that. And here's a second chance for some of you guys to get your hands on a reproduction of some of those cool maps/posters. All you have to do to check that out is to go on a link under the video. It's a Teespring merch shop, and I have put up some of the posters there. So if you like them and want another chance, maybe this could be for you.